Hi guys, you're watching channel Mr. Electron, and today in this video I'm going to salvage some useful components from an old dead 1 kilowatts 20 years old home inverter. So guys, here as you can see that finally I have managed to salvage this huge transformer from the inverter. As you can see, it is really big, and for comparison I'm going to use this small UPS transformer, and you can see how small this piece is when compared to the inverter transformer. Now these 4 wires that you see, these are quite thin, and if we move on to the other side, you see these wires, these are really thick when compared to the other side. So this side is going to be your high current low voltage side, so the other one is going to be your high voltage and low current side. Now comes the part of finding out which wires should we connect to the supply. So here I'm going to use this multimeter, and let's point the meter to resistance checking mode. So first let's check these 2 wires, and here we have 3.3 ohms. Now let's go for these two, 4.5, which is a little higher. Now the last one, 4.7 or 6, so it is the highest of the rest. So we are going to use these 2 for connecting to the mains. But before you proceed with that step, always perform the series connection test. So for that you are going to need one 100 watts bulb and connect 2 wires like this. You see, these are jumper wires. So 2 wires connected over here like this. Next, take one of the wire and connect it to the transformer. So now we have 2 left out wires in total, this one and this one. So these 2 will be connected to our home socket supply. So I'm going to use this for powering up my transformer. 1 wire connected. Now comes the other one. Yeah, and here we are done. Now let's turn on the switch. Now this bulb should glow a little bit if it's working. I'm not sure if it is glowing or not. Yeah, and now it is glowing. I think you can see. I'm going to turn off the lights. So it is glowing, really dim, but yes, it is glowing. And the next part is measuring the voltage at the output wires. So for that, I'm going to reuse my multimeter, and this time the pointer has to be set at AC voltage measurement mode. So yes, I think it's clear enough. first I'm going to measure this voltage. As you can see that it is 9.68 volts AC. So of course it is working. Let's move on to the other one, and this one is also the same, 9.68. Now this one and this one, and it is as high as 20 volts AC, quite high. So yes, our transformer is working perfectly fine. And one final thing, short circuit these two wires. Okay, I'm going to touch them and the bulb should glow brighter. You see, it's glowing bright, which means that the wiring that we have done is perfectly fine. Same for the other one, and these two also. Nice. So here we have a great salvage this time, a huge transformer. So this time it is a little dangerous. One wire connected, comes the other one. Now let's turn it on. Nothing happened. Okay. Well, I didn't hear any humming sound. So let's connect this bulb at the load. You can see it is 24 volts and 250 watts. Okay, so turning it on once again. Yeah, so the transformer is so efficient that there is no humming sound at all. It is silent, actually silent. Nice. Now let's increase the input power to the bulb, since it is a 24 volts bulb, and the good thing is that we have that combination. Now turning it on once again. You see, it is much brighter this time. Wow. Let's turn off the lights. Turning it on. Whoa. It is smoking hot. So that's our bulb. It's connected like this, and this time I'm going to turn it on and let you hear the humming sound. Let me know if any. Do you hear anything? So here I'm going to do some ampere measurement. 600 amps. So at present it is DC. Now it is AC RMS. Turning it on. Here we have around 9.5 amperes. Nice. So guys, finally the components that I have salvaged are one socket, two switches, high ampere switches, one small transformer for operating the relay, one PCB with so many components and heat sinks, MOSFETs, one huge relay case for future use, and most important, a transformer, 1 kilowatt transformer. Now guys, this is what I 3D printed this time. So this is the screw, and it's going to go like this. So link to buy this product has been provided in the description. You can check it out from there. And yes, of course, it is free for first 12 hours. So this is how you are going to assemble it. Now comes its use. So this, what you see, is a multimeter, and at the back of it you can see the double-sided tape. So all you have to do is take your multimeter, it can be any multimeter, and stick this piece at the back of it like this, and you're done. So this piece is going to be your multimeter stand. Okay, it works quite nice. Now here, as you can see, that the display is really dim, so I'm going to adjust it. And here we have it, even better this time. So this is how we are going to use it. It's quite simple and easy, and the best part is that this stand does not make this meter bulky. It is still quite handy. You can still use the clamp meter without any problem. And when you need the stand, you just open it and you have it. Hi guys, today I'm going to make a 1 kilowatt lithium ion power station using dead old laptop batteries. So the battery cells required for this project are 156, therefore it's 1 kilowatts. Now here we have the lithium-ion batteries that we salvaged from the old laptop batteries. So it's time to check which ones are working and which ones are not. Dead. Dead. Working. Working. Not sure. So I'm not sure about these four. These are working and these two are completely dead. Now if we have a closer look on this piece, you see it's completely rusted and this battery is corroded, while this one seems fine. So it means that this battery might have taken down this one as well with it, because they are connected in parallel. So let's separate them and try to revive the other one. Yeah, these both are gone. So now comes my 3D printed cell balancer that I made in one of my previous videos. Link for the 3D print will be provided in the description. You can check it out from there. So here, as you can see, it's negative. This one is also negative, although we can see that there is some glue present. So we will have to remove it with sandpaper. It's fine now. So this is how it's going to look after you have completed the placement of cells. It's beautiful, isn't it? So let's charge it. At present, the cell voltage is 3.39 volts. Now to charge these batteries, I will be using my old computer power supply. So that's your supply. You see this black collection of wires. Take one wire, it is going to be ground, and the red one being your 5 volts positive. So to the ground wire, I'm going to connect 2 diodes in series to reduce the voltage from 5 volts to 4.2 volts, 4.2, 4.25, somewhere around that. And that's how I'm going to charge these batteries to full. And I'm also going to use this voltage ampere meter. Link for this product has also been provided in the description. You can buy it if you want. And guys, remember that this black wire will be left disconnected. Okay, so this red wire will be connected to the negative of your battery pack, and this tapping point, red one, will be connected to the positive. So at present the display is 0 because and you can see that there is some fluctuation. That is because the batteries are not charged enough to power it up. This runs at 4 volts, so I will have to power up my power supply. So here, as you can see, it's indicating 3.7 volts, and the flowing current through the diode and the wires is 4.2 amps, and I'm charging 8 batteries at the moment. So after some time, here as you can see, the meter is showing 4 volts with an input current of 1.8 amperes. So finally it's fluctuating to 4.1 volts, which is good enough for the batteries. So I have to repeat the process with the rest of the batteries. Now guys, I've placed another set of dead batteries this time. Okay, and that's the meter, it's still not on. So here, as you can see, the open circuit voltage. Now let's connect positive and the negative. You can see the meter just turned off because the voltage of the batteries is so low that it cannot even operate. Like the voltage from the power supply has dropped to the level of the battery, because of which this is getting like a voltage less than the rated, and now we are close to it. It is fluctuating, and here you can see that the drawn amps are as high as 8 amperes for 3.5 volts. That's a lot of current for lithium-ion batteries. Battery is heating a lot. These two, only these two, I think these are like not so well. So now it's drawing nominal current 4 amps. That is acceptable, but these two were drawing huge currents. So after completing the charge balancing part for the batteries, it's time to weld them together, for which I will be using my next 3D print. Link has been provided in the description.
Next level.
So guys, now that the positive side welding is complete, let's move on to the negative side.
Next level.
So let's test the battery voltage, and here we have 3.9 volts. So this is how we are going to use this 3D print for making our battery packs 8x2 16 batteries. So here, as you can see, that I've made 3 sets, and each set is capable of 82.3 ampere hours each. Now the next step is apply wooden board and your battery sets. So this is the positive side and this is your negative side. So it's going to be placed like this. Now take the other one and place them like this, and here I'm going to use this cardboard as the separator. Now comes the third one. So this is going to go in reverse like this one, negative up, and again separator. So after completing this much, we will move on towards connecting the 3 battery sets in series. And since it is not like a single cell but 32 cells connected together to make one big set, so this time we are going to need thicker nickel strips to carry that huge current. So this is the one that I'm going to use this time. It's much thicker than before. So guys, now that the series connection of the batteries is fully complete, let's test it, and you can see that it is working. So this one is a 55 watts bulb. Here, as you can see, 12 volts, 55 watts. So let's check the battery voltage, and here we have 11.73 volts. A little bit discharged. It's fully charged at 12.5. So now comes the use of my 12 volts 40 amps BMS 12.6. Now guys, here as you can see is the BMS, and the strips, I have welded them, all of them, to the positive terminal of the BMS. You can see this is positive and this part is also positive, so that it can transfer huge current with the 3 strips. So here as you can see is my 4 mm wire that will be placed like this, but first I should place some flux. So here as you can see that I've strongly soldered this wire on the positive terminals, these two, to utilize full possible current, and also on the strips. So this is going to be great. Now comes the 0 point. This will be connected to the negative. Now comes the part of connecting strips to the ground terminal, which is 0. Okay. Now I'm going to add another strip on this side to increase up the carrying amps. The welding part on the 0-volt terminal of the BMS is complete. Now I'm going to make it even more stronger by soldering it. Other side of the 0-volt terminal. So after the 0-volt terminal comes the negative terminal, the overall negative of the BMS. Now the negative one is also complete. So for 4.2 I will be using this green wire. And for 8.4 I'm going to use this red one. Done. So guys, that's the 0-volt overall negative terminal, and I've welded it to the overall battery negative. You can see. Now comes the green terminal. You see this one? This has to be connected to the 4.2 volts. So the 4.2 volts wire has also been connected. Now comes the final 8.4 volts wire, the red one. So the BMS connection to the battery pack is finally complete. Let's connect this 55 watts bulb and test it. Let's hope it works. Okay. Yo, so we are doing really good here. Here, as you can see guys, that I've finally completed my battery pack. So now it's time to conduct its full testing. Starting with the voltage test. Here we have 11.71 volts DC. Now let's do the weight measurement, and here as you can see we have 4.2 kgs. So guys, here we have the clamp meter, and I've placed it to this wire, the blue one, positive one. So let's move the pointer to DC current measurement mode, and that's a high current DC motor. I will show you its winding thickness. Here as you can see it's quite thick. So let's try this one. Okay, let's see the peak amperes. Whoa, you saw the peak amps were around 15, 16. Moving on to the next high current motor, this is a bike starter motor. Now I'm not sure if this can run it or it's gonna get damaged, but I gotta try this. Okay, keep watching the multimeter display. Whoa, 22 amperes. I think the BMS is protecting itself by turning off. So let's make sure that everything is fine with the battery pack and the BMS. I'm going to connect this 55 watts bulb and also see the amps this one draws. So it's 5. So now I'm going to test my next high current motor. It's 24 volts, 500 watts. So let's try this one. It's quite heavy. I'm going to hold it steady. So 15 amperes. 18. So 18 was the maximum current that we saw displayed on the screen of the multimeter. So that's that. Now let's see how much voltage we are left with now. So at the beginning of the test we were around 11.71 volts and great, it is still the same, 11.71. Obviously the battery is huge. Now guys, this BMS can handle a maximum of 13.6 volts DC. So I'm going to use this variable power supply. Yeah, that is 13.6. Now this one. Now when I'm going to connect this wire, the voltage here displayed should drop. See, 12.5. Oh, the current drawn is huge. So here if you can see, it is drawing 5.5 amperes, even though this piece is rated for a max of how much is it, 3 amperes. So at present I have to feed huge current. This is like needs a lot of juice, so this charger is going to feed it. Yeah, so guys, now my battery pack is fully charged. Let me show you the voltage. Here as you can see, it's showing 12.4 volts, which is pretty good. It was initially 11.71 and now it is 12.42. Now guys, for my power station project, I will also be using one more battery pack, this one, which as you can see I'm connecting in parallel to the previous set. So the two batteries have been connected in parallel and the overall voltage as you can see for both the sets is 12.15 volts. So let's test this bike starter motor this time. Okay. Whoa! As you can see, it works now. The current is huge. Close up.
Next level. level. Next level.
Now guys, before moving on with the project, I would like to introduce you to a new machine, which is my cordless soldering iron. Link to buy this has been provided in the description. You can check it out from there. So that's the close-up. Here as you can see that it is 8 watts and a 4 volts soldering iron with a maximum temperature of 450 degrees. So to turn it on, you have to hold it for like a few seconds, and they have also provided these illuminating LEDs, and yeah, it's on. And to turn it off, you have to fast press it 2 times, and that's your holder. You have to keep it like this. It's quite cute. And for charging it, we have this cable. It's gonna plug in at the back of it, and this is going to be connected to your normal mobile charger. Plus they have also provided these 2 solders. That's for your tip cleaning. This one is gonna go here. Nicely done. So guys, this what you see is an LED electronic driver circuit which I'm going to use to power up my 100 watts LED light.
level. Next level. Next level.
So this is the 12 volts 17 amperes power supply, and these are the 220 volts pinouts which I have connected to this point so that I can charge my power station.
Next level.
So now when I'm going to connect the power supply, the charging will start. So let's connect the charger. Here I'm going to show you. At present, at just 13.2 volts, it is drawing around 10.2 amps. Now the battery will finish when the voltage reduces from 12 volts to 9.5 volts, so it's still a long way to go. And this one is 100 watts LED light, and I'm charging my cordless screwdriver and 2 mobile phones right now.
For rope rotation testing. Now comes the no load current flow to this motor at 12 volts input. Let's do that check. Let's point it towards 10 ampere mode, okay?
Hi, this what you see is an old vacuum cleaner motor, 1000 watts with some major heating issues. So I thought about reusing its impeller for another project of mine. So here I will be using this 24 volts 16,500 RPM DC motor. And that's my 24 volts power supply. Link to buy it has been provided in the description.
Next level. Next level.
This what you see is a 1.5 volts to 32 volts DC to DC buck boost converter module with a constant output voltage which can be adjusted with the potentiometer knob. So here I'm adjusting it to 24 volts as required by our DC motor. So at the moment I'm charging the batteries with this one. They are really discharged. In the meantime, let's connect the impeller.